Hey guys, Mr. B here, and in this video we're going to be going through the practice problems of chapter 14.4 on simple machines. So let's begin here with number 1. It says, name 6 kinds of simple machines, give an example of each. Alright, so we have, first one was the lever. Second one we have, and these might not be in the order that they were listed in the notes, but second one we have was the wheel and axle. Oh, I forgot. Sorry, you should give an example of each. So lever, example of a lever is a teeter-totter. Okay. Wheel and axle, example will be maybe a wheel and axle on a car. Third one we had was the incline plane. So example could be like a ramp used by movers, right? So like if you move your house, if you're moving houses and they have a bunch of boxes, they got to push them up a ramp. Fourth one we have was the wedge. So an example of a wedge could be like an axe. Otherwise, you could also use like a doorstop, right, under the door. Number 5 we had was the screw. This one is going to be a screw. I don't know a good example on that one other than, I guess some of this. A corkscrew. How about that? A corkscrew. Obviously, a screw is a screw, but a corkscrew. There we go. And then number 6, the last one was the pulley. And a good, I don't know, I guess an example of a pulley would be a pulley. I don't know. That one, obviously, some of these ones are a little bit kind of self-explanatory. But anyway, so those were the 6. Oh, sorry. I'm looking at number 2. It says, describe how to determine the ideal mechanical advantage of each type of simple machine. All right, so we're going to duplicate this slide because we're kind of running out of space here. I'm just going to delete number 1. All right, so let's delete this question here, and let's put it on this second slide. All right, so describe how to determine the mechanical advantage of each type of simple machine. So for levers, okay, so lever is, you're going to be measuring distance. So for lever, you need to take your input distance divided, oh, hold on, let's make sure we underline this properly. And actually, let's go back in our notes too, just to make sure that we're doing this right. So for the lever, you can take your input distance divided by your output distance. Okay, this is going to be ideal mechanical advantage. So lever is going to be input distance divided by output distance. For the wheel and axle, we're going to take the radius, radius of wheel, and we're going to divide that by the radius of the axle. And let's make our font smaller here so we don't run out of space. There we go. For the incline plane, it's going to be the same as the lever. Okay, input distance divided by output distance. Though the input or the output distance in this case is going to be the height of the ramp. So how high it's lifting the object. For the wedge and the screw, these are going to be the same as the lever and the plane. So say same as, we'll say same as incline plane, because the wedge is 2 inclined planes put together, and the screw is an inclined plane that goes around a cylinder. So as for the pulley, we need to count number of strings pulling up on the object we are lifting. Okay, so for the pulley, to determine the mechanical advantage, you count the number of strings pulling up on the object that you are trying to lift, and that is listed right here. Okay, all right. Number 3, how are the lever and the wheel and axle related to each other? All right, so this is an interesting question. Now the lever and the wheel and axle aren't obviously the same, because the lever is something that pivots and a wheel and axle is a wheel and a cylinder and it rotates, but they are related, okay? And they are related in the fact of how we determine the mechanical advantage. Now here we wrote down input distance divided by output distance, and this is also the same thing, okay? Input distance is our radius wheel and output distance is our radius of axle. So how are they related? They are related in the fact that to determine their mechanical advantage, you have to do the same calculation, okay? So we can say they are related because to determine their mechanical advantage, you need to do input distance. Let's make our font smaller here too so you don't run out of space. Input distance divided by output distance, okay? That's how they are related. And this is going to be equal to ideal mechanical advantage, or IMA. Okay, that's how they're related. All right, number 4, what is the ideal mechanical advantage of a ramp if its length is 4 meters and its higher end is 0.5 meters above its lower end? All right, so mechanical advantage for a ramp, and this was written here on this one, is input distance, which is the length of the ramp, divided by output distance, which is the height. So to find our mechanical advantage for this, we are going to take length of the ramp. So IMA is equal to 4 meters. So 4 meters, that's the length of the ramp, divided by 0.5 meters, which is the height of the ramp. And this will tell us our mechanical advantage. So let's take 4 and divide this by 0.5. And we get a mechanical advantage of 8. Okay, that is our mechanical advantage. So, all right, number 5. Tightening a screw with a larger spacing between its threads requires fewer turns of a screwdriver than tightening a screw with smaller thread spacing. What is a disadvantage of the screw with larger thread spacing? Okay, so this again is going back to what machines do. Okay, remember, if distance increases, then force decreases. Okay, and vice versa. So we'll say and vice versa. So in this problem, they are telling us that we have a screw with larger spacing. And it says that will require fewer turns. So larger spacing, fewer turns, that means our distance is going down. Okay, it is decreasing our distance. The disadvantage of that then is that the amount of force we need to use is going to be larger. So it will be more difficult to turn a screw with threads that are further apart because we will need to use more force on every single time we turn our screwdriver. So we can say that if the spacing of the screw is large, if the spacing of the screw is large, then the distance of the ramp, which is going around the screw, is small. This would mean that the amount of force needed to turn the handle of the screwdriver will be large. Okay? So if the spacing on the screw is large, that means that the total distance that the ramp that goes around the screw is small. And if you have a small distance, that means you have a large amount of force. And that means that every time you turn the screwdriver, it's going to be hard to turn. Okay, that's what that is saying. All right, number 6. What class or classes of lever always have a mechanical advantage greater than 1? So we have 3 classes of levers. Okay, we have first class, second class, and third class. And to determine the mechanical advantage of a lever, we have to take the input divided by the output. So for a first class lever, if we put the fulcrum, and let's zoom in here, if we put the fulcrum way over here by the output, then the input arm is going to be very large. The output arm is going to be small. So if we take a large input, let's say this is 10, right? 10 divided by a small number like, I don't know, 1, we're going to get a mechanical advantage of 1, which is pretty good. Okay, so first class levers can have a mechanical advantage greater than 1. Okay, that's one type of lever. So let's go put that down on our answer here. Okay, so what types of levers can have mechanical advantage greater than 1? First class lever can. Okay, first class lever can. Let's look at a second class lever. So second class lever, here is our input, here's our output. If we put the output further towards the fulcrum, if we put the output closer to the fulcrum, so the input is going to be from the fulcrum to where we're pulling. Okay, that's our input distance, which again will be large. If we take our output and put it close to the fulcrum, then that distance from the fulcrum to the output will be small. So like in the first one, we have a large input and a small output. That will give us a large mechanical advantage. So a second class lever will also give us a mechanical advantage greater than 1. So we also can say second class lever can give us a mechanical advantage greater than 1. What about a third class lever? So let's take a look at a third class lever. So third class lever, our input is in the middle. So, and our output is on the outside, which means that even if we put our input all the way over here by our output, it will always be shorter than the output will be. Which means that when we do the math here, the input distance, even if it's 10, the output distance will always be a little bit larger. Okay, in this case, maybe it's, this is not working the way I want it to. There we go. So even if the input distance is 10, the output is always going to be a little bit larger, which in this case might be 11, because again, the output is always going to be outside the input. The input's always in the middle. So this means that a third class lever will never give you a mechanical advantage greater than 1. So in our answers here for this question, when again it asks what classes of levers always have a mechanical advantage greater than 1, first class can and second class can, but never a third class. Third class lever. Okay, so third class levers will never give you greater mechanical advantage greater than 1. All right, number 7, if you want to pry the lid off a paint can, will it require less force to use a long screwdriver or a short screwdriver? Ooh, interesting question. All right, so this question goes back to this whole premise here. If you increase the distance, then you decrease the force. So if we have a long screwdriver, we are increasing the distance through which we are pushing. If we have a short screwdriver, that distance is shorter. So longer distance means greater force, okay? So long distance means greater force, whereas a short screwdriver, the distance is small, therefore the force is also small. So if you want to pry the lid off a paint can, will require less force to use a long screwdriver or a short screwdriver. It will require less force to use a long screwdriver. Okay, so we will say here that it will require less force to use a long screwdriver. Again, large distance, small force, right? So large screwdriver, long screwdriver means we have to use a little amount of force to push on it. All right, last two questions here. Number 8, when the pedals of a bicycle move through a distance of 0.25 meters, the rear wheel of the bicycle moves 1 meter. What is the ideal mechanical advantage of the bicycle? All right, so to calculate mechanical advantage for a wheel and axle, which this is what this is, right? Bicycle is a wheel and axle. So IMA is equal to, again, for wheel and axle, radius of wheel divided by radius of axle. So the wheel in this case is going to be 1 meter, because it says here the rear wheel of the bicycle moves 1 meter. So this is going to be equal to 1 meter. And the axle is going to be the distance that the pedal's moving, so 0.25 meters. Okay, so take 1 and divide it by 0.25, and this will give us our mechanical advantage of the bicycle. So let's take a look here. So 1 divided by 0.25, and we get a mechanical advantage of 4. All right, last question. Explain why it could be useful for the mechanical advantage of a bicycle to be less than 1. So this question is basically saying, why would it be useful to have a bicycle that instead of making it easier to pedal, you have to use more force to pedal, right? So if you're pedaling a bicycle, it's usually not that hard to pedal and get your bike moving. However, you can certainly put your bicycle in a lower or in a higher gear, which will make it more difficult to pedal, right? So if you ever put your bicycle in, like, you know, gear 10 or something, it's like really hard to pedal. You got to really use some leg muscles. However, what's the advantage of putting a bicycle in gear 10? So the advantage of this is, even though it requires more force to push on the pedals, okay, so the force is larger, the wheels are going to spin more, faster, okay? So you're essentially going to be going quicker because the rotations per minute, or RPM, of your wheels will be higher, okay? So higher gear basically means you can go faster, whereas if you put it in a lower gear, like gear 1, it's really easy to pedal your bicycle, but it doesn't really go that fast, right? So we can say the advantage of having a mechanical advantage less than 1 is that the bicycle will go faster. Also, another advantage is if you're trying to build up some leg muscles, you're going to build more muscle if it's more difficult to pedal your bike. So that's also an advantage, is you're building muscle, but regardless. So, all right, anyway, that is the last question for this section of notes and pretty much the chapter. So hopefully that helps clear up some confusion or helps you with anything on simple machines. But again, as always, if you have any questions, make sure that you reach out. Okay, you can email me, talk to me in class. We could always sit down and do a Google Meet or something, but make sure that you get your questions answered. All right, guys, that's it for this one. I'm Mr. B. I'll see you in the next one. Bye.